Conditional expressions are one of the basic features of programming. The most common conditional expression is the if-else statement. Here's a very simple example showing the general structure of an if-else statement. The basic idea of this chunk of code is to print the reciprocal of A unless A is 0. So we type if A is not 0, print the reciprocal, else print no reciprocal for 0. You can run the function now with A equals to 2 and you get a different answer than if you run the function with A equals to 0. Here's a general form of an if-else statement. We type if and then a condition. We call these Boolean conditions. If that is true, the expression in the brackets following that condition are performed. If that is not true, then the alternative expressions encompassed by the else brackets are performed. Let's look at some more examples using the U.S. murders data frame. We load the data frame and define the murder rate variable. And now we ask the question, which states, if any, have murder rates lower than 0.5? The if statement protects us from the case in which no state satisfies the condition. So we can write something like this. If the smallest state has a murder rate less than 0.5, print out the name of that state. But otherwise, say there's no state with murder rates that low. So if we use 0.5, we get the answer Vermont, because that state has a murder rate lower than 0.5. But if we change that level to 0.25, we get a different answer. Now we say no state has a murder rate that low. A related function that is very useful is the if-else function. One word, if-else. This function takes 3 arguments, a logical and 2 possible answers. If the logical is true, the first answer is returned. If it's false, the second answer is returned. Here's an example. Define A as 0, and we ask if else A bigger than 0, return the reciprocal, otherwise return a missing data. If we apply this function, we get back missing data. But the function is particularly useful because it works on vectors. It examines each element of the logical vector and returns the corresponding answer accordingly. So let's look at an example. Let's define A as 0, 1, 2, negative 4, and 5. Now the result here is going to be the reciprocal if A is positive and a missing data if it's not. This table helps us see what's happening. In the first column of the table, we have the first vector. In the third column, we have the first answer. In the fourth column, we have the second answer. In the second column, we have the conditional. If the conditional is true, the first answer is returned. If it's false, the second answer is returned. So let's go down the list. 0, is it bigger than 0? No. So we return the second answer, the missing data. So the result column has an NA. Second one, 1, is it positive? Is it bigger than 0? Yes. So I'll return the first answer. 1 divided by 1 is 1. That's what I return. Second one, is 2 bigger than 0? Yes. I'll return the first answer, 0.5. Negative 4, not bigger than 0. I will return NA, the second answer. And finally, 5, which is bigger than 0, gets a true, and we return 1 over 5. Here's an example of how this function can be readily used to replace all the missing values in a vector with zeros. This is a very common use of this function, replacing NAs with some other value. For this, we're going to use an example that's included in the DS Labs package. It's the NA underscore example. And we can load it like this. And we can see by using the sum of is NA example that there's 145 NAs in this vector, which contains numbers and NAs. So what we want to do next is create a new vector called no underscore NAs that replaces all the NAs with 0. Using the if-else function, we can do this very easily like this. Once we're done with this, we see that the new object no underscore NAs has no more NAs. All right, 2 more functions, any and all. These are also quite useful. The any function takes a vector of logicals and it returns true if any of the entries is true. So here's an example. If I apply any to the vector true, true, false, I get a true because at least one of them is true. If I apply it to false, 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 I get a false because none of them are true. The all function takes a vector of logicals and returns true if all the entries are true. So here's an example. If z is true, true, false, and I ask all z, I get false because they're not all true. If I make z true, 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 then of course I get a true because they're all true.